One of the important restrictions that are placed on our data tables is that every row or record must be uniquely identifiable. There has to be one piece of information that you can use to identify exactly one record with absolutely no ambiguity. This particular field is called the table's primary key, and it's the value that we'll use when it comes time to link our related data tables together. Let's suppose one of our customers has an issue with a product he ordered. We can go to an orders table to look up information about the transaction, but how do we find it? The customer first gives us their name, which will show us all the transactions that they've completed with us. Hopefully it's a bunch. This is good to know, but it doesn't find us a specific transaction. They could tell us the date they placed the order, but again, that would return all of the orders placed on the same date and not identify their own specifically. This is why we have something like an invoice number column. It helps us uniquely identify a specific transaction in our table. Think of all of the numbers that are identified with you personally. You have a Social Security number issued by the federal government, a driver's license number issued by the state, bank account numbers, a library card number. All of these numbers are essentially primary keys in somebody else's database system that are used to uniquely identify you as a separate person from everyone else that might share your name. Primary keys are incredibly important and one of the core components of a relational database. Because of this, there are several rules put into place when it comes to creating primary keys. The first rule is that a primary key must be a unique value. After all, that's the entire point of a primary key. Second, it cannot be left blank. It absolutely needs to have a value. Third, it needs the value created as soon as the record is created. There is no opportunity to fill in part of a record and come back and give it a primary key later. It all needs to happen at the same time. And fourth, primary keys cannot be changed once they are created, except in very extreme cases and with a lot of careful planning. To identify keys, we'll look for fields whose values are dictated by other fields. In the world of database design, this is called functional dependency. Looking back at our invoices table, the customer, date, product, method of payment, and so on are all dependent on the invoice number and will change from invoice to invoice. Sometimes there will be a value that you're already keeping track of that meets all the requirements of a primary key. It's likely that we'll already be keeping track of a receipt number if we're using pre-printed receipt books, which is a great choice of a primary key for our invoices table. These are called natural keys, values that are already present in the data that can become the primary key. However, if we don't find any columns that are suitable, then we'll need to create a new column in our table specifically to take on the role of primary key. This goes by the name of surrogate or synthetic key. It's often some sort of serial number or something that the database generates automatically as records are created. Surrogate keys will often not support any specific business need and are useful only to the DBMS. Here's an example. If we look through our employees table, we don't see anything that jumps out as being suitable for a primary key. The name field certainly won't be unique, as we'll probably have lots of employees named Susan or David, and we'll also likely have employees that share a last name. It's also not inconceivable for two different employees to live at the same address or share the same phone number. Not seeing a suitable candidate for a primary key, we'll decide to create one for the table by adding an additional column. So what data are we going to put here? You might already have a number that you use internally, but if not, we'll create one now. And since this isn't a number that we're particularly interested in, we'll let the DBMS just assign values as new records are created by taking advantage of the internal auto-incrementing feature of the system. Primary keys are typically only a single field or column in the data table. However, they can also be composed of two or more columns, a situation that is called a composite primary key or a concatenated primary key. When two or more columns combine to create the key, each individual column can contain duplicates, but the combination of values must be unique. In certain situations, this can be a very useful way to store your data. Let's take a look at an example. Suppose you work for a local water board and need to keep track of the wells in your area. One of the things you want to keep track of is the location of each well by storing the latitude and longitude. If we set up our data table with an auto-generated or surrogate key column, something like well ID, then we'll have a situation that looks like this, where each well gets a new ID number and the latitude and longitude values are associated as additional columns. The problem that arises is that there is nothing in this table structure that prevents me from creating two wells in the same location, something that would be really hard to do in the real world. For instance, in this table, it indicates that well number 2 and well number 1 are at the exact same latitude and longitude. While there is clearly an error here, the rule that a primary key cannot be duplicated hasn't been violated. So as far as the database is concerned, this is a completely valid situation. Instead, what we can do is create a composite key, saying that it is the unique combination of latitude and longitude that provide the primary identifier for each well. Now our database is protecting us from invalid data entry. We can have lots of wells in a row at the same latitude and lots in the same longitude, but only one well at any specific intersection of latitude and longitude. Now, if needed, we can add back in an ID or a name column to make each well easier to identify in an annual report, for example. But the primary way this database will keep track of our wells is through the composite key. Finally, primary keys provide the main connective tissue through which the database keeps track of relationships. Once we know the primary key for a specific customer, for example, we can go back to our invoices table and replace their name columns with this same unique identifier. What is called the primary key in the customers table becomes something called a foreign key in the invoices table. So that's what you need to know about primary keys. They provide the unique identifiers for every record in every table in your database. It's through the use of these keys that we're able to make relationships to other tables and ensure that the DBMS is able to keep track of our network of connections across the entire system. At this point, you'll want to return to your data model and note which fields are going to serve as the primary key for each table. Typically, this is done by drawing a little key icon next to the field name or indicating it with a PK abbreviation after the name. If you find your tables don't have a suitable key that will uniquely identify each record in the table, then you'll need to add one using some sort of serial number or auto-incrementing number. Finally, we'll use those keys to provide more specific linkages as we further develop, not just that two tables are related, but by what specific fields they'll relate. So for every relationship in your data model, ensure that there is a copy of the primary key field from the parent table in each related child table.